So the basic ones we did yesterday when we first started talking about solving exponentials already had the one-to-one, meaning their bases were the same on the left and the right. Okay, then we got into those more complex. So here, these look a little more complex. These are more like the later examples we did yesterday. You can see in this first one, 32 is the base on the left, 16 is the base on the right. They do not match. So I have to try to figure out what values I can replace them with so that they do match. So remember, I'm going to start thinking about a base value that's raised to a power that may give me this number. So I know 4 squared gives me 16. That's one of the replacements we did yesterday. Will you close that door all the way for me, please? But now I need to ask myself, is there 4 to some power that would also give me 32? Well, if I do 4 times 4, I get 16. If I multiply by 4 again, is that 32? No, 16 times 4 is not 30, 16 times 2, but not times 4. So I can't change them to base 4s. So I have to think smaller. Okay, so then I go down to a base 2. So then I'm asking myself, let me get my pen here. Yeah, that's the one. Okay, off to the side, you can jot this down if you need to. I'm going to start with the 16, the smaller value, and I'm going to ask myself 2 to what power would give me 16? If anything, I don't know for certain that it will, but I'm going to go through and try. Okay, so I'm going to say, okay, 2 times 2, that's 4, times 2, that's 8, times 2, what is that? That's 16. So how many 2's are there? So that means 2 to the 4th power is 16. So I can make that substitution of 2 to the 4th power. Now I'm going to try and do the same thing with 32 so that I have a matching base 2. So 2 to what power would give me not 16, I started to write the same number again. 32. So I already know that 4 2's is 16, and then times 2 again. What's 16 times 2? That's 32. So it took 5. So 2 to the 5th power is 32. So that's the replacement I can make. Now everything else stays the same. There was no other power on the 32, so it's just 2 to the 5th. But over here, I've got negative x plus 2 as the exponent. We talked yesterday, we reviewed our exponent rules, and we said, okay, when you have a power to a power, we have to multiply those powers. Okay, I'll jot that rule up here again. If you have a power to another power, an exponent on an exponent, you multiply those exponents by each other. So here, one of my exponents is just an integer, but this exponent's a binomial. When we multiply a number by a binomial, what do we have to do? Am I multiplying the 4 just by this negative x or just by this 2? If I have a number times a binomial, I have got to distribute. So if you need to write this out this way to see the distribution happening, write that step. Some of you will do that step up here in your head. You'll say, okay, I got to multiply that 4 by both of these. And that's fine. And you'll jump straight to here where you say, okay, that's going to be negative 4x plus 8. And on the left, our exponent is just 5. Okay, the way we got from this step to this step, remember, is that once you have those matching bases, once this is set up 1 to 1, we can just drop the bases and set the exponents equal to each other. Because if 2 to the 5th power is to equal 2 to all this other stuff, then those powers must be equal. 2 to a power equals 2 to a power. The powers have got to be equivalent. That only makes sense. So now we've got our basic, like, pre-algebra problem. I'm going to isolate the x. I'll move the constant to the other side. If you have a coefficient, then you'll divide out that coefficient. So I've got positive 3/4 is a negative divided by negative is a positive. And what did we talk about yesterday when we first introduced this about how we can check our solutions? Yeah, you can take that x value that you think is the solution and plug it back into the original equation. Perfect. We're going to have a fire drill. Okay. Well, I guess I won't start the next one. I'll stop this video here, and the next ones will be on a second video. When we come back in, hopefully we'll have time to do another 1 or 2 together. Let's stop this video here.